Welcome to Learning Labs with Cornerstone. I'm Kira.
And I'm Philip. In Learning Labs, we will take the Cornerstone Educational Supply lesson plans a step further and perform the experiment hands-on with tips and tricks for what to look for when performing your experiments. A Pharisee named Nicodemus came to see Jesus. He wanted to talk with Jesus so he could understand who Jesus was and what God was doing through him. Talking with Nicodemus, Jesus said this, "The wind blows wherever it pleases. You hear its sound, but you cannot tell where it comes from or where it's going. So it is with everyone born of the Spirit." John 3:8. We can't see the wind itself because the wind is made of invisible air, but we can hear it, and we can feel it, and we can see some of its effects on other things, like when it moves the trees. To move the trees, air must have mass, and the only way for air to have mass is if it's made up of other matter. What kind of matter is invisible to us? Well, the air is made up mostly of two gases. Nitrogen gas makes up 78% of air, and oxygen gas makes up 21%. The remaining 1% is mostly argon gas and tiny amounts of other gases, like carbon dioxide. Not all gases are invisible to us, but these four are, so we can't see the gases that make up the air. Because air is made up of matter, it has mass. And because the atmosphere is very, very thick, there is a lot of those gases on top of us. That means all that mass is putting its weight on top of Earth's surface and us. We call this air pressure. Air pressure is the weight of the air's mass above us pushing down on us. But air is not just on top of us. Air is a gas that is all around us, and that means that air pressure pushes on us in all directions, up, down, left, right, front, and back. Now we'll show how we can tell that air can not only push down, but it can also push up.
Welcome to Push Up. In this experiment, we will demonstrate the strength of atmospheric pressure. The materials for this experiment are a mason jar, an index card, water, a few sheets of white paper, ice cubes, yellow and blue food coloring, and an incense stick. Start with a mason jar that is 1/3 of the way filled with water. Place an index card on top of the mason jar and put your hand flat on top of the index card. Flip over the mason jar as quickly as you can. Slowly remove your hand from the index card.
Whoa, why did the index card stick to the bottom?
Air pressure is pushing up on the bottom of the card, and the amount of air pressure pushing up was more than the weight of the water pushing down on the same card. Here are some discussion topics for your students. What would happen if there was no card on the lid? The water would fall out. What would take the place of the water inside of the jar? Air would go into the jar. So, if the air is trying to get into the jar and the water is trying to get out, then the card is blocking this, right? But that doesn't mean that air still doesn't want to get in. The pressure of the air trying to get in is holding up the card. Air pressure pushes down on us, and up, and front, and back, with a force of almost 15 pounds per square inch. That means that the air is pushing the card up at that force too. But the weight of the water is only pushing down on the card by a few pounds per square inch. Since the bigger force is pushing the card up, then the card will not fall. So now we can see that air pressure can push things around. We can see air's effects even though we can't see the air itself, just like Jesus told Nicodemus.
All gases are fluids. This means that they are a type of matter whose particles, which are atoms or molecules, can move freely, fill a container, and respond to stress by flowing. Liquids are also fluids. So we'll look at how a fluid behaves with water first, then come back to see how air behaves in a similar way. Fill a mason jar with water. You can put a piece of white paper behind the jar in order to observe this experiment better. Add a couple ice cubes to your jar, and add 1 drop of yellow food coloring to the jar. Did you see the food coloring move around in the jar? How was it moving? Was it mostly side to side, or was it up and down? You should have noticed that the food coloring was going down, below the ice cubes. it may have reached the bottom of the jar or started spreading out a bit above that. Then, streams of food coloring flow upward towards the top of the jar. If you watch carefully, you'll be able to see areas of sinking water and areas of rising water inside the jar. Let's repeat this experiment, this time using a different colored dye. We'll use blue this time. Add some more ice to your jar and observe. The food coloring goes down because cold water from the ice is dense and sinks, while the food coloring went up when it was in warmer water that was less dense and rose upward. Since both water and air are fluids, air will do the same thing as water. Air rises when it's warm and sinks when it's cool.
We used food coloring to see fluid motions in water, but that won't work with air. Instead, we will use an incense stick. As the incense burns, it will produce smoke. This smoke is made up of tiny little particles of the incense that are lifted by the hot air made by burning the incense. This allows us to see what is happening in the invisible air. First, light your incense stick with matches or a grill lighter. After it burns for a bit, you should blow it out to see visible smoke. Hold the incense stick still so your students can see the smoke. Notice where the smoke is straight and when it becomes turbulent and wavy. Put the incense stick out by dipping it into a mason jar filled with water. Here the incense smoke is doing the same thing as the food coloring. It is helping us see the movement of fluids. In our atmosphere, when air gets warm, it will rise, and when it is cool, it will sink. The straight line of smoke just above the incense stick is where air is rising smoothly and rapidly. But the further away the smoke gets from the incense stick, the more it starts to slow down and swirl. This is because it is running into cooler air that does not get out of its way so easily. At some point, the hot air cools and no longer rises. The fact that hot air rises and cool air sinks is really important because it is the basis for all of our weather. When warm air rises, it goes up into the atmosphere and eventually cools to make clouds. If there is lots of moisture in the air, it may also rain. When cool air sinks down from the sky, it gets warmer as it gets closer to the ground. When air sinks, it does not make clouds. Instead, we get clear blue skies and sunny weather. By observing the food coloring and the incense smoke, we can start to see how air moves up and down in our atmosphere.
And that's week 18. Thanks for joining us, and don't forget to have your Cornerstone Lesson Plans handy to help you with this week's lesson. Thanks for watching, and we'll see you next time.